Hi. So today I'm going to talk about another aspect of dimensional modeling, and which allows you to model situations where we have multi-value dimensions. So let me begin this lecture on multi-value dimensions. So topics for today include multi-value dimensions, bridge tables, which is a solution to modeling multi-value dimensions, and I'll take you through some example modeling situations. So multi-value dimensions, so let me give you some background about this. So once we declare the grain of the fact table, right, and declaring the grain of the fact table is one of the important design decisions, because it controls the amount of data that will be there in the data warehouse. And second is that it defines the dimensions that are going to be involved. And the grain declaration gives a meaning, gives an exact meaning to each and every record in the fact table, right? And if the grain of the fact table is clear, choosing the dimensions become easy. So that's what I said, that once the grain of the fact table is known, right, so the dimensions automatically emerge from it. So it's an important design step, declaring the granularity of the dimensions and the facts, right? So let me give you a situation, right? So this is related to a bank case study. Okay, so which will come immediately after I complete this particular submodule, right? And so the situation is like this. So there are accounts in a bank, and banks basically target households rather than individuals. They target households. So there is a household where you have two people, John and Mary Smith, and John has a current account, and Mary has a savings account, and also John and Mary have joint current account and a joint credit card. And an account can have 1, 2 or more customers associated with this. So any account, say if I have a joint account, right? So my account number is 100. So if I have a joint account, so I'll have A account holder, B account holder, and there are 3 account holders. If there is another account where there can be only 2 accounts, right? So A1, say account holders B1. Okay, there can be another account which has only 1 account holder, and there can be an account, say 150, which has multiple account holders. So A dash, B dash, C dash, D dash, and so on, right? So an account can have 1, 2 or more customers associated with it, and at the same time a customer can have multiple accounts. So account 1, account 2, account 3. Like in this case, John has a current account. So John in this case has a current account. It has a joint current account, and they also have a credit card, right? So it's a kind of a many-to-many relationship between the accounts and the customers. Okay, so this is a typical setup. So let me clear this. So let me clear the annotations. Okay. So customer is an account dimension attribute. So there'll be because the bank is interested in the accounts. So the main connection between the bank and customer is an account, right? So it knows the customer through the accounts. So in most of the analysis, the accounts are important, not the customers directly. It does not mean that customers are not important, because only customers will open up an account, right? But from a design perspective, right, accounts are the ones that are directly linked to everything, right? Okay. So customer, so what I can do is I can try to model a customer as an attribute. So suppose this is my account dimension, right? So if I have a customer attribute in this, so now you have seen that an account can have multiple customers. So I don't know how many fields I should reserve for customer. So should I have only one customer customer attribute, or two, or three, or for that matter 10 or 20? You don't know, right? So if I put this account in the account dimension customer, if I put this customer as an attribute, doing so violates the granularity of the dimension table, as more than one customer could be associated with an account. So customer as an additional dimension in the fact table, right? So if I now I'm saying that I create a new dimension called as the customer dimension. Now if I do this, this violates the granularity of the fact table, because there is only one row per account per month. So as I told you, the fact tables are all with respect to accounts, and there are multiple customers associated that could be associated with a particular account. So if I try to do this, model it as a dimension, then also there is a problem. So this is a classic example of a multi-valued dimension. So now the question arises is that how do we model such a situation? I have discussed two possible solutions with you in this slide. One is that I try to model it as a attribute in the account dimension, but that is not scalable, because you don't know which account would have how many customers associated with it. That is the problem with that. And if I model it as a customer dimension, then the fact table is at a much coarser granularity, that is an account, right? So I cannot have a customer dimension which directly talks to the fact table. So how do we model this particular situation? So let us see what we do. So the solution to this is what is called as a bridge table, right? So what we do is, so this is my fact table. Okay, so you can see there's an account ID, there's a surrogate key for account, okay, and there's this account dimension which is directly talking to this, right? And there are attributes, so let us not talk about those attributes at this point of time. So we create a customer dimension, but this dimension does not talk directly to the fact table. It does not talk directly to the fact table. So what we do is we kind of link the account dimension and customer dimension through what is called as a bridge table. So what we do is we have an account ID, okay, and we have a customer ID, and this two form the primary key for this. Okay, so what it allows me to do is say that account 1 customer 1, account 1 customer 2, account 2 customer 3, account 3 customer 4, account 3 customer 4, account 3 customer 5, and so on. So you can see that A1 has two customers, A2 has only one customer, A3 has three customers, and other accounts will have different number of customers. So, and for the time being, don't talk about this weight, and this weight is kind of being removed, right, from the analysis altogether. So all the modern modeling techniques do not recommend the use of weight, so you can just remove this weight from here, right? So what you have, so you can now see a customer can participate in multiple accounts, so that is possible through this bridge table between the bridge table and the customer. And an account can have multiple customers, so that is captured in this bridge table, right? So now what I have done is that I have added a bridge table between the account dimension and the customer dimension. Customer dimension does not directly talk to the fact table. It talks to the fact table through the bridge table and the account, right? So if you were to do some analysis of a customer, like how valuable this customer is in terms of his balance, in terms of his transaction, then you'll have to enter the data warehouse through the customer dimension, and then see which all accounts. Suppose I wanted to do this analysis for say, okay, let me add one more row here, account 4, and this is C4. So C4 has how many accounts? Is associated with A4 and also with A3. So what I'll do is, so this A4 and A3 I'll get from this bridge table, and then I'll use those account numbers A4 and A3 to join with the fact table, and then I do, suppose I'm storing one of the facts is balance. So suppose I wanted to check the balance of this particular person, right, over a period of or you can say over a period of a month, what is the maximum balance that he has, right, in these two accounts. So that I can do. So this is the solution to multi-value dimensions. So now let me give you some other situations under which you would do this. So this is how, so this is another same kind of figure which talks about the connection of fact tables. So this is a monthly snapshot. So typically banks do not indulge in day-to-day snapshots, so they do a monthly snapshot. So you have an account dimension like in the previous slide, then this is the bridge table, and this is the customer dimension, right? So this is another depiction with some kind of attributes being added here and there. So another situation where we can very easily talk about multi-value dimensions. In the classical grocery store sales data mart, the following dimensions are obvious for the daily grain. So date, product, store, and promotion, right? What about the customer and checkout clerk dimensions, right? So what happens is, suppose there is a say I'm putting today's date, say for example, say 1/6/15, okay, and then product is say P1, right, and then store is say S1, and promotion is no promotion, suppose, right, and then I have some kind of fact. So suppose total units sold, so that is say suppose 50. So what this means is that on 1st June I sold 50 units of product P1 from store 1, okay, and there were no promotions on P1 on 1st June in store 1. Now these 50 units of product P1 were bought by multiple customers. It is not bought by a single customer, right? So suppose there are 3 customers who bought in some ratio this particular product P1. So suppose one bought 20, another also bought 20, and the third bought 10. Now if I wanted to, and the customer numbers are like C1, C2, C3, right? So how can I associate with this record multiple customers, right? So this is again the same kind of situation. So when you have an account, so this is just like an account. So suppose this is the date, product is a savings, and bank branch is say Pilani, and promotion is no, right? So it's a savings account, and there will be an account number, right? So that account number is say 100, and the balance is say 10,000, right? So this is what I have. Now this account 100 has 3 customers. So how do I associate customers with this? So that's what, the same kind of problem in a different setup or in a different case study like a grocery store sales. And also these 50 products, 50 units of this product. So when I was selling this product, there was a salesperson 1 who was at the sales desk, right? Then the duty changed, and when these two kind of products, these two customers came, there was a salesperson number 2 who was at the desk, at the sales counter, right? So there are two salespersons who are associated with it. So how do I associate these two values, or these two salespersons, with a one record of the fact table? So that's the problem. So that is what is multi-valued dimension. And so typically you will see that many values at the daily grain, many customers associated with one row, and many salespersons associated with one row. So how do we model the situation? So there are some solutions which I wanted to discuss, although I have told you this the main solution for this particular problem, that is use bridge tables. So one solution is that we disqualify the customer and checkout clerk dimension, or the salesperson dimension. So we say that since they are multi-valued for one record of the fact table, I don't want to include them. And as a result, what may happen is that many dimensions can get disqualified if you are dealing with an aggregated fact table, right? Because when you aggregate the data, many of the dimensions do not apply, right? So if I'm talking of a fact table which is at the daily grain, and then I talk about a fact table which is aggregated at the monthly at the monthly granularity, right? So maybe some of the dimensions, promotion dimensions, may not apply, right? So when we aggregate, less number of dimensions apply, and when we this is also called as roll up. And when we drill down, which is the opposite of aggregation, when I am seeking more details, then that is called as a drill down. So when we do drill down, more and more dimensions would apply, and when we roll up, less and less dimensions would apply. So the more fact table is summarized, that is aggregated, the fewer number of dimensions we can attach to the fact records. And what about the converse? Converse is also true. The more more granular the data, the more dimensions make sense. So single valued dimensions are always welcome, right? And so any legitimate exceptions, that's what we are dealing with, multi-valued dimensions. If yes, how to handle them? The solution for this is bridge tables. And another example that I want to associate with this is the healthcare billing. So grain is individual line item on a doctor hospital bill, right? So individual line items guide us through to the dimensions. So this we know now, right? So let us see how it looks like. So the dimensions involved, let me clear this. So dimensions involved are like calendar date, on which date means the date on which the charges were incurred, the patient, the doctor, we call him the provider, the location, services performed, diagnosis, and the payer. Payer could be like the insurance company, the employer, or the person is paying for self. In many healthcare situations, there may be multiple values for diagnosis, right? So there can be multiple values for diagnosis. Like for example, a really sick person or a really sick people having 10 different diagnoses, it is a very common situation. So how to model the diagnosis dimension, right? So that's what we want to discuss now. So this is again a situation of multi-valued dimensions. So again I'll discuss the possible solutions for this, and let me come. So the first is that disqualify the diagnosis dimension because it is multi-valued. So this is not recommended. Choose the primary diagnosis and ignore others. So you just have one value. So instead of multiple values, I say that I don't treat it as a multi-valued, but I'll just take the most prominent diagnosis, or the primary diagnosis as we call it, and record only that. So primary or admitting diagnosis is only recorded. So modeling problem is taken care of, but is the diagnosis information useful in any way? Because suppose a person is suffering from heart disease, right? and he also has diabetes. So if you are not recording that, the treatment, proper treatment cannot be given to the patient, right? Because we don't know whether he suffers from any other problem or not, right? So the third solution is extend the dimension list to have fixed number of diagnosis dimension locations. Now this is the same as the earlier situations that we have discussed, that suppose I say that I fix that an account can have only 5 customers associated with it, and I record only the 5. So this may or may not be true for all accounts, right? So some accounts may have 10 customers associated. So which 5 do I include, right, or do I record in my data warehouse, right? So those are problems that come in, right? Similarly, a product is bought by, say, 10 customers, and I have only 5 slots. So what do I do with the remaining customers, right? So all the analysis would get affected if I take this kind of an approach, or a fixed kind of slots approach, right? In the account dimension, in the customer dimension, and so on, right? So this is also called as a positional design, and positional design is not scalable, because I just explained that a patient can have any number of diagnoses, so you cannot fix the number of diagnoses that you want to record. Okay, so that's what we are saying here. There will be a complicated example of a very sick patient who exceeds the number of diagnosis slots you have allocated. So multiple separate diagnosis dimension cannot be queried easily. So if headache is a diagnosis, which diagnosis dimension should be constrained, right? So these are all problems. So you cannot have multiple dimension diagnosis dimensions also, because we don't know which diagnosis is in which diagnosis table, right? So if headache is a diagnosis, which diagnosis dimension should be constrained? So we don't know that. So avoid multiple dimension style of design, as logic across dimension is notoriously slow on relational databases, and also it is not very well supported in relational technology as also. So we don't take this kind of an approach. So what we do is, let me clear this annotation here. So sometimes the grain of the fact table is clear and easily understood. Also the dimensions are obvious and not controversial. But you can see here, so if I include this diagnosis dimension here, right, so there are multiple values. So this crow feet towards the diagnosis dimension tells me that this is not a desirable modeling situation, right? So what we do is we include this bridge table, right, again. So now you can see where is this bridge table sitting. It is sitting between the diagnosis dimension and the fact table. And if you recall the bank example, right, bank account example, it was sitting between 2 dimension tables, between the account dimension and the customer dimension. So it depends on the modeling, on the situation, that where this bridge table has to be positioned. So the fact table now contains a diagnosis group key. So what we do is we create a diagnosis group bridge table, so which is this, and here we have a group key 1. So it would have all the individual diagnoses. So suppose let me write it so that you understand it better. So diagnosis group key 1, say, right, 2, 3, 4. So suppose there are 10 different in a particular hospital, there are 10 different diagnoses, right, 10. So I'll have a group key for each one of them. So this is, say, for headache, right, this is for, say, heart related problem, this is, say, diabetes, and this is for, say, some other problem, okay, say cancer, like this. I have 10 different diagnoses. So I'll have 10 such records, and then I'll have combinations of them. So suppose there's a person who is suffering from diabetes and also from heart disease. So there'll be a key which is 12, which is nothing but a combination of heart disease and say diabetes. So like this, every conceivable combination is stored in this bridge table. Okay, and whatever attribute, and in this table I record each individual diagnosis. So here I'll have only 10 records in this dimension. Here all possible combinations I can either store them proactively, or as there is a new combination that emerges, I keep on storing this in the group dimension group bridge table. So this is how I model it. So you can see that the problem is the same multi-value dimensions like in case of account and bank accounts, and here in the case of diagnosis this is coming from the healthcare sector. So the position of the bridge table is different and nothing else changes, right? So okay, so this is okay, this is not this is bridge table. So bridge table clearly violates the classical star schema, right? Classical star join design, where all the dimension tables have a simple one-to-many relationship to the fact table. So in a typical setup, what we have is this: a fact table, this is a dimension table, and it is a crow feet on this side always. That is, one dimension record would have multiple entries, right, in the fact table. But it is only a viable solution. It is the only viable solution to multi-value dimensions, where you can also have something like this, a crow feet opening towards the dimension. And positional design is not scalable, because that is where we try to create slots, right? So that is not scalable, as we have seen. So we can preserve the star join illusion. So bridge table is the only solution to this, but some, as I told you earlier also, some OLAP tools that allow you analysis on top of a data warehouse, they insist that the database is a classical star schema, and not any distortion of star schema would be acceptable. But when you do this, you are creating a kind of a distortion here by adding a bridge table, or you are trying to have a bridge table between something like in the case of account. So you have another dimension here which is linked to an existing dimension through this. So in either case there is a distortion to the classical star schema. So what is recommended is that any distortion that happens has to be kind of hidden under a view definition. So what I can do is I can do a join between these two tables and represent them by a single table. So that is what is typically done. So in the next few lectures I'm going to talk about role-playing dimensions and dimension hierarchies. So here basically there are two kinds of hierarchies: fixed depth and variable depth. Okay, and then we have factless fact tables, and we have role-playing dimensions. So these are the things that are going to come up. So basically what we looked at today is that how do we model multi-value dimensions, and these are very common. Like I gave you 3 examples at least in this lecture, right? And there can be many more such examples. So as you go through different case studies, you will come across many such scenarios where there are multi-value dimensions. So the solution to this is that we create bridge tables wherever appropriate, depending upon the situation. And sometimes, like I'll just take one more minute to just explain one more point which I think I forgot. So you can see that here there is the primary key is a combination, right? And here there is there is a diagnosis group foreign key. So this is not typically allowed, right? Okay, so one key, because this is referring only to a part of the primary key, right? So what they do is they insert another table here, which is again, I mean, you can name it anyway, and there is only one say diagnosis group key. That is only one attribute in this, and that is the primary key. So this talks to this. Sorry, let me redraw this. I'll clear this whole thing. So what happens is that this is a foreign key which talks to this, right? And here there is a composite primary key. So some RDBMSs do not allow this. So what we do is we create another table in between here. So I'll use another ink so that. So what we do is we create another table here, which is where I keep only the one single field. It's a single field table, diagnosis group key, which is the primary key of this. So this dimension or this thing talks to this, and then this thing talks to this. Okay, so that's how it is modeled. So that kind of solutions are also proposed. Okay, so depending upon again the situation. So with this I end today's lecture on multi-value dimensions. So in the next class, next lecture, I'm going to talk about role-playing dimensions. So which is that a particular dimension like the time dimension, which is common, right, appears many times in the star schema. So how do we handle that situation? So next lecture is on that, and then I'll talk about hierarchies and factless fact tables. Thank you.